We're doing statistics year 2 revision, statistics year 1 Edexcel IAL revision. Okay, so our first chapter is measures of central tendency. Come on, tell me, what do you know about it? What are measures of location?
Measures of location are maximum, minimum, quartiles, percentiles, and deciles.
What is measure of central tendency?
Mean, median, mode.
Okay, mean, median, and mode. Okay, so if you want averages, you take mean, median, and mode. This is also called measures of central tendency. When you talk about the measure of location, it is the minimum, maximum, quartile, decile, and percentile. When you talk about the measures of spread, what does that mean?
The range, standard deviation, variance, interquartile range.
Okay, fine. So measures of spread, what does that tell you?
How much the data has spread.
Okay. Can you tell me what are the different types of data you know about?
There's quantitative and qualitative.
Okay, what is qualitative data? What is quantitative data?
Quantitative data is when it includes a number of stuff, and qualitative data is when more on the it's not on the like related to numbers or something.
Okay, so quantitative data can be divided in two parts. What is it?
Quantitative,
Yeah, quantitative data. Quantitative data, that is the numerical data, can be divided into two parts. The first part is your discrete data. When I talk about discrete data, means what?
certain values.
Discrete random variable that we are dealing with.
What?
Discrete data, is it the discrete random variable?
Yeah,
It takes specific values. Which values it will take?
specific values.
When I talk about continuous data, the chapter that deals with the continuous data, that means it takes any value in a given range. Okay, what is continuous data?
Takes any value in the given range.
It's value in given range. So when we talk about the continuous data, which chapter are we dealing with?
Chapter 1.
Normal distribution. Okay, we are dealing with normal distribution. Can you give me examples of continuous data?
1.5 height basically.
Height. What else could be the examples of continuous data?
Time,
And
and it could be
okay, the height, the time is examples of continuous data. Now let's talk about the mean. What is a mean?
is the mm, is the average.
Mean is the average. How do you write the mean?
X bar.
X bar. Okay, what is n?
Sample size.
Okay, mean can be calculated for raw data and grouped data. How do you write the mean for raw data?
X bar is equal to sigma x divided by n.
When it is a frequency distribution table, means it is mean is for which data?
Mean is what?
When there is a frequency distribution table, what does it denote? We are calculating our measures of central tendency for which data?
For f
Grouped
of x.
data.
Yeah,
We are calculating for which data? Grouped data.
grouped it.
Okay, we are calculating mean. Mean is denoted by sigma x and we write fx. What is the f?
Frequency.
What do you mean by frequency?
The number of things. Number of.
Number of times that the x will happen.
Yeah.
Okay, x could be the group data or it could mean classes. So whenever classes are there, we have to ensure the classes are always
Continuous.
continuous. Continuous means there are no gaps between the data. So when I have the mean of a grouped data, it would be mean x is equal to summation fx divided by summation f. How do you calculate combined mean?
X bar is equal to N1 into X bar 1 plus N2 into X bar 2, divide the whole divided by N1 plus N2.
Okay, what is median?
Median, it is the center number.
Okay, what else? Median is the
It
second
is,
number. It is also called your
yeah.
second quartile. It is the n by 2 value.
Hmm.
Okay, median is Q2. If you get an answer in your decimal number, what do? You will round up. If you get an answer in the whole number, then you take whatever number is there, take the next data value divided by 2, you will take the average. Are you with me?
Yeah.
When I talk about mode, what does mode mean?
Mod, it means the number which is repeated the most often.
What is a modal class?
Class interval with the highest frequency.
Okay. So when I'm talking about location, what does a location describe? Location describes position. Okay. Location is always describing the position. And when I'm talking about the position, if I have a single value, center of the data, we use measures of central tendency, and we have three measures of central tendency. What are they?
Mean, median, mode.
Okay. What is measures of location?
Measures of locations are going to be quartiles, percentiles, deciles.
Okay. What is measures of spread?
Measures of spread are going to be uh, variance, standard deviation, interquartile range.
So whenever you're calculating the median, there is one thing that you should always remember. What is the thing that you should remember?
We should arrange the data in an ascending order.
Okay. Now we talk about our measures of location. So measures of location is quartile, decile, percentile, and median. Quartile is going to divide your data into
4 equal parts,
decile,
10 equal parts,
percentile,
100 equal parts,
and median.
2 equal parts.
Okay, if I'm calculating the median, I would do n plus 1 divided by 2. Whatever that term is there, that would be my median. Right?
This is only true for the odd values, right?
Yeah. So if you have an even number, you take the n by 2 value and the next value after that.
Okay.
Okay. That means if my n is 10, that the data is even. So I will take the 10 by 2. That is the fifth observation and the sixth observation divided by 2. Yeah.
Yeah.
If it is for the odd number, then what will I do?
N plus 1, the whole divided by 2.
Okay. Now we talk about quartiles. First quartile is also called the lower quartile. Can you tell me about quartiles?
Yeah, the lower quartile, which is basically n divided by 4, it means that it represents 25% of your data.
Okay.
And then Q2 is median, basically. So 2, 2n divided by 4,
Okay.
which is 50% of the data. And then Q3, which is the upper quartile, is basically 3n divided by 4,
Hmm.
which represents 75% of the data.
Very good. Okay. Now, some key facts about your discrete data. If you're getting answer in a whole number, what will you do? You will take the average. If it is a decimal value, round it up. Yes, yes.
Yeah.
Quartile is going to divide your data into four equal parts. I have Q1, Q2, Q3. I would see my this. This is 1, 2, 3, and 4. It is dividing the data into 4 equal parts. This is the first 25%, first 50% plus first 75%. With me, what is interquartile range? What is interquartile range? Tell me what is an interquartile range?
What?
Interquartile range?
Interquartile range is basically Q3 minus Q1.
Q3 minus Q1. Okay, now percentile. What is about percentile?
It divides the data into 100 equal parts.
Okay, so whenever I'm finding percentile, what will I do? I will divide by 100. So
Hmm.
if it is P1, I will take n plus 1 divided by 100. If it's P2, then I will do 2n plus 1 divided by 100. So this is 1% of the data, 2% of the data. If I have Px, then it would be x% of the data. So whatever is over here, I will write over here and then I write n plus 1 divided by 100. When I talk about P100, what is P100?
Percentile 100, so like 100% into the data.
100% of the data. What is interpolation?
Linear interpolation is used to estimate values.
Which values?
Measures of location.
We're talking about interpolation, that means you're estimating your QDP. What is QDP?
Yeah.
What is QDP?
Quartiles, deciles, median,
Yeah, quartile,
percentile.
deciles. Okay. So from a group frequency diagram, when you're estimating any value, you use the method of linear interpolation. Okay. But when you're using your linear interpolation, you have certain things that you need to know. It should be a group frequency distribution table. Your classes have to be continuous and you need to have a column for cumulative frequency. Do you remember the formula for linear interpolation?
Yeah.
Tell me. It
L
is
plus L plus P minus CF the divided by F into H.
okay. So it is L plus P minus CF divided by F into H. When I talk about this estimated value, it is actually the range that we are looking at. Up to this range, this much data will belong to this class. Is it true?
Yeah.
Okay. L is what?
Lower bound.
Lower bound. P would be the position. Okay. The cumulative frequency of the
Yeah.
desired quartile, decile, or percentile position. CF would be the cumulative frequency of the previous class. Are you with me? This with the
Yeah.
cumulative frequency of your desired quartile, decile, or percentile position. This would be cumulative frequency of the previous class. This would be the frequency of the class of your QDP. Yeah, and height would be the class width. I hope you are with me.
Yes, yes.
When you're using linear interpolation, say I want Q1. Are you with me? Say I want
Yeah.
Q1, so Q1 I will do n by 4. N by 4 is 8.75. Come on, tell me where does 8.75 lie?
It's going to be the position.
At which class will it lie?
Uh, 10 to 20.
It will lie over here. So this is the cumulative frequency of the class containing QDP. This is the cumulative frequency of the preceding class. This is the class containing QDP.
Yeah.
And this is the cumulative frequency of the preceding class. Now, when I'm talking about the
Mm.
estimated value, it will be L plus P minus CF divided by F into H. So this is my class, right? This is the L,
Yeah.
then plus P. What would be the P? Position
Mm.
minus cumulative frequency
Class
of the
width.
previous class
Yeah.
divided by frequency
Mm.
of the current class into 10.
Class width.
Okay, so it will give us the range. Q1 would be 14.69. Are you with
Yeah.
me?
Mm.
Are you with me? That means 14.69 data values lie in Q1.
Okay.
Remember the worms example?
The worms. Mm.
Example, just go through it and explain me. So this is one example of linear interpolation that is going to help us solve other examples. So our linear interpolation formula is L plus P minus CF over F into H. Are you with me?
Yeah.
Yeah.
We are looking to find the number of slow worms above 217.7.
Mm.
Okay. But this formula is going to give me the number of slow worms up to 217.7. Are you with me?
Mm.
Yes.
We are looking to find above 217.7, but this formula is going to give me the number of slow worms up to 217.7. Okay, I have the lower boundary of the class that contains 217.7. I am trying to find the number. I am trying to find the P, the number of slow worms up to 217.7. Minus CF, I will have the cumulative frequency of the preceding class. Divided by F, I have the frequency of the class which has 217.7 multiplied by the class width. So I get my P, which represents number of slow worms up to 217.7. Are you with me?
Yeah.
Now
Yes.
this is my class. Up to 217.7, I have 63.13 slow worms. Are you with me?
Yeah.
Total number of slow worms is how much? Total slow worms is how much? Total, overall. What is the cumulative frequency of the last class?
The
7.
total cumulative frequency is 71.
71.
And up to 217.7 is how much?
Up to two,
63.13.
yeah, 63.1.
63.13. So if I want above 217.7, what will I do? I will do 71 minus 63.13. So I have approximately 7.867, or I say I have approximately 7 worms who lie above 217.7 millimeter. Please go through it. Let's talk about the variance and the standard deviation. When I'm talking about variance and standard deviation, you remember what is variance and standard deviation? Measure of,
Variance is, yeah.
measure of.
Measure of spread.
Okay. And for that, we remember which formula? Miss Selma Merchant. Mean of the square minus square of the mean.
Yeah.
Yeah. We remember this formula, right? Mean of the square minus square of the mean. So variance. Variance tells us how much my data is deviating from the mean. How much my data is moving away from the mean is what the variance tells us. So for variance, standard deviation is written as like this, and variance is the root of the standard deviation. I hope you are with me. The formula for variance you will be given in your formula sheet. Okay. Mean of Miss Salma Merchant. So mean of the square minus this is the mean of the square. Are you with me?
Yeah.
And this is the square of the mean. There is another way to find variances. You do Sxx divided by n. You get the variance. Are you with me?
Yes.
Okay. Sxx is also founded by summation x square minus summation x by n the whole square. This all will be given in the formula sheet for you. Again, can you give me the formula for variance, please? I'm giving you a minute's time. Please write it down. Formula for variance. Mean of the square minus square of the mean. Please write it down. Mean of the square minus square of the mean. Formula for standard deviation would be square root of mean of the square minus square of the means. The way you write it is very important. Haris, the way you are writing is not correct.
Yeah, 1 minute. I need to just ask the explanation.
So what does our variance tells us? Variance tells us how much my data is moving away from the mean. Okay, variance will tell us whether my data has more variability or my data is clustered around the mean or my data is away from the mean. If I have a small variance means my data is just moving around the mean. If I have a large variance means my data is more spread out. With me, to find the variance I would need x square, fx square. Okay, you're going to simply plug it into the formula. If you're having a group distribution table to find the variance, first you write the formula for variance that you remember. Miss Salma Merchant, please write along with me. It would be mean of the square minus square of the mean. But if you just have an f, you will put f here next to the x and cancel the n and write summation f. This is variance. And standard deviation would be the root of your variance. I hope you are with me.
Yes.
I'm taking you to the next topic of coding in statistics. What do you remember about coding in statistics?
Coding makes it more manageable or easier to work with.
Okay, it
Yeah.
makes it more manageable and easier to work. So if I am coding my data, I have original data and I have the coded data. Okay, so my coded data is smaller than the original data. It is easier to work. If you have huge sets of data, then you prefer to work with coding. Okay, so in statistics, you can use coding for your measures of location and you can use coding for your measures of spread. Can you tell me your coded data? Mean will get affected by which operators?
Plus,
Plus,
minus,
minus,
division,
multiplication,
multiplication.
division.
And in your coded data, your standard deviation will get affected by which operators?
Only multiplication, division.
Only multiplication and division. That means your mean of the coded data will change because of plus minus multiplication division, but standard deviation is only going to change because of multiplication and division. It will remain unaffected because of plus and minus. Are you with me?
Yes.
Yeah.
Okay, fine. I don't think you'll need this. Okay. If my code is y is equal to 2x plus 5, can you give me the standard deviation of the coded data? My standard deviation of original data is 14.1. Can you give me standard deviation of coded data?
If your uh what's
This
it called? Standard deviation is 14.1,
hmm,
and this is the code, so you'll only multiply 14.1 into 2, which would give you 28.2, which is gonna be your standard deviation.
okay, very good. Okay, so mean is affected by operators, of by all the operators. Standard deviation only by plus and minus. Are you with me? Now I'm giving you a time. There are these 12 questions that I have put forward for you all. I want you to answer these 12 questions. I'm pausing the video.